Finally, we are at a point where we can test the DQN algorithm against CartPole. We'll use CartPole because it will give us quick feedback. There are a couple of things that I added that I want to point out before we test the code. In my agent.py file, up near the top, I added code to create a runs folder. This is where we're going to store our log, our graphs, and our trained model. Down here where we're checking if GPU is available, sometimes GPU is not necessarily faster than running on CPU. There's an overhead to moving data onto the GPU. Sometimes that overhead is not worth it. If you want to force to use CPU, just add this line right here. Let me go down to my agent class. Added a few lines here to store the log file, store the model, the trained model, and store our graph. It's all going to be under the runs folder, and it's going to be named after whatever the hyperparameter set is. So first I'm going to test CartPole-v1. It's going to be named CartPole-v1.log.pt.png. In our DQN module, we take in the hidden layers dimension. I've defaulted it to 256, but for something like CartPole, we don't need that much. So I added a hyperparameter here. I set it to 10 for CartPole. This is where I read it from the hyperparameters. I'm going to pass it into our DQN right here, both to the policy and the target network. Continuing down, this is where we initialize the variables. If it's not training, then we want to load the policy from our trained model and then switch our policy network to evaluation mode. I also added a variable to track the best reward collected so far, and I initialized it to a really small number. Now let's see where it's used. Down here after the episode loop, after collecting the rewards, if the episode reward is greater than our best reward, we want to save the model and set the best reward equal to the current best reward. Inside our episode loop here, where we keep running until the episode terminates, for an environment like CartPole, it's possible to train to a certain point where the pole never falls. If it never falls, then it never terminates and we're stuck in this infinite loop. So I added this stop on reward parameter, which I added to the hyperparameters.yaml file. And for CartPole, I set it to 100,000. Down here, I added a save graph function. This is where we're going to graph the rewards per episode and the epsilon history. I'll leave it to you to read this if you want. Finally, to make training and testing easier, I added some arguments here. If we want to run in a training mode, we'll just pass in the hyperparameter set name and pass in --train, and this will kick off the run function in training mode. Without passing in --train, we'll run in test mode and render the environment to the screen. Now let's test our code against CartPole. We should be able to get feedback pretty quickly. I'm going over here to run and debug and create a JSON file. I'm going to name this configuration train CartPole-v1. The file that I want to run is agent.py. I also want to pass in arguments. I want to pass in CartPole-v1, also --train. Now with this selected, I can hit this button or I can hit F5. We see that training has started. We see that we're constantly improving. Let me go back to my files. Under my runs folder, the same log that we see down here is also saved to file. We can take a look at our graph. On the right side, we can see epsilon has decreased all the way down to the minimum after maybe 5,000 episodes. On the left side, we can see the average rewards per 100 episodes. You can see that it's improving. You can see that it's making some pretty good jumps here. It has reached the best reward of 1,400. Over the course of training, you're going to see fluctuations, but if the model is constantly improving, you're going to see an upward trend. If we think that epsilon decreased too fast, we can go into the hyperparameters and adjust it and rerun it, or we can make a copy of this Name it CartPole-v1. Open a new terminal. Notice that the current one is still training. In the new terminal, after we adjusted some of these parameters, my advice is to change one thing at a time, keep the rest constant, so you can see the difference between the current set versus the previous set. Let's say I slow down my decay. Over here, I can kick off another training. Pass it CartPole-v2 -- train. You can see CartPole-v2 log best model being created, and here's the graph. We can see that the epsilon is decaying much slower than the previous one. However, the improvement is a bit slow. So if we don't need to run in debug mode, we can just run it as a Python command here. If you want to start in debug mode, you can come here, either change this to CartPole-v2 or create a whole new set of configuration, and you should get the CartPole-v2 on the drop down here. Since there doesn't seem to be any bugs in the code, we can just launch additional sessions straight from the command line. Depending on how fast your computer is, you can start as many sessions as you want and try different sets of parameters. Let me pause the video and let it train for a few minutes. Okay, I just hit Ctrl+C to kill both of the training sessions. I actually ran the test yesterday and I copied in these 3 files from yesterday. Let me show you what happened. So it started at 21, let me see, from 21 to 46. In about 20 minutes, CartPole was able to reach 100,000. And after 100,000, we're not going to get any more printouts because this is the stopping point that we set. It's not going to improve any more than this. And it took 69,000 episodes. I'm sure if you mess around with the hyperparameters, you might be able to shorten this to a few minutes. Let's look at the image. The image shows the mean reward of 100,000 near the end of training. We have the trained model. So let's run the trained model to make sure it actually works. I'll do Python agent.py CartPole-v1 without the -- train. We'll run in test mode. Let's see what it looks like. Okay. You can see the cart trying to balance the pole. If it goes off the screen, it's going to terminate. Is it gonna survive? Wow, okay, had me worried there for a second. Looks like it's coming back. Let me speed up the video a little bit. Looks like it found a happy point around this spot. Okay, I think it's going to balance here indefinitely. I think our code is good. We can use it against Flappy Bird. Let's take a quick look at the hyperparameters configuration, the difference between Flappy Bird and CartPole. Of course, my environment is different. Replay memory, batch size, keeping all that the same. You can see the decay rate is lower. Epsilon minimum is the same. The network sync rate is the same. I slow down the learning rate. Discount factor is the same. Stop on reward is the same. The number of nodes in the hidden layer, I made it 512 versus 10 up here. Since Flappy Bird is a much more complicated environment, also Flappy Bird has an extra parameter to turn on or off LiDAR. This just turns it off. So I can start the training the same way. Agent.py Flappy Bird 1 -- train. At the beginning, we're going to get some tiny improvements, but this environment is going to take quite a while to train. I'm going to stop the video here. Join me in the next video where we review the results and hopefully see Flappy Bird fly.